good afternoon, and good evening for the various places that you are from. Today, we have Aarti, the ambassador of WIDS Brussels, with us, who will host the session. And also, there are a couple of sessions that are lined up, the details of which will be shared by Aarti. Aarti, I hand over the session to you. Welcome. Aarti, I think you're on mute. I'm sorry.
Yeah, I'm back. Hi, everyone. Hello, everyone. Thank you for joining us. So, Women in Data Science. So this is an event that started in 2015 as a one-day technical event at the Stanford University. And from there on, over the last 6 years, it has grown into many regional events as well as datathons and podcasts as well. So it all started as a one-day technical event when Professor Margaret noticed that there was a panel discussion about diversity and there was not a single woman in it. So this Women in Data Science conference is dedicated to showcase the achievements of women data scientists and also to learn from them and their achievements. What we did in 2021, so the WITS Stanford conference were a 24-hour conference covering all the regions from APAC to America. This happened yesterday and we had 2,000 plus attendees from 65 plus countries, and there were 200 plus events as a part of this one-day conference. There were workshops, networking events, as well as panel discussions. And in Brussels, this is the first time that we are doing. And I thank Maya also in supporting me as an ambassador to arrange all these sessions. We are kicking off the session today. We have 8 talks lined up. And I thank DeFi for helping us with the platform as well as the community outreach. So moving on, I'll introduce today's speaker, Dr. Lida. She is an AI specialist and data scientist at Microsoft. She works closely with customers and partners on providing AI and machine learning solutions using Azure cloud technologies. Prior to joining Microsoft, she was a research scientist at IBM in Australia, where her focus was on cognitive computing and semantic technologies. Lida is passionate in applying her skills and experience within NLP applications and solving real world problems of language. Today, she is here to talk about her experience solving in building a question and answering application on the Kaggle data. Thank you so much, Lida. I hand it over to you.
Thank you so much, Aarti, and hello, everybody. It's a pleasure. Hello, can you hear me?
Yes, I can hear you, Lida. Yeah. You can continue.
Perfect. Very good. Would you be able to put my slide, please? I shared my screen. Yes, if you want me to share my screen again.
Yes, please. Yes, please.
Yep. So do you see this screen now?
Yes, Lida. It's visible. Yes, Lida. It's
perfect. Visible. Perfect. Just switch the. Perfect. Yes. Hello, everyone. Thank you so much for joining this call. I also thank the Women in Data Science in BERT region and DeFi who supports the live sessions. Today I am going to walk you through solutions that I have submitted for Kaggle competition, and please feel free to put your questions on the chat window. I'd be happy to answer them at the end of the talk, and I can have a look at them once you putting them, but I might not be able to answer at the same time, but we will have enough time to walk you through it at the end of the session. And having said that, let's start by in the spirit of this moment, this great festive time that yesterday was International Women's Day. I thought we could start this talk by this video that always inspired me, and I like you enjoyed it as I enjoyed it.
My favorite subject in school is science because you can invent all different kinds of cool things and there's like no limit what you can do.
One inventor is Benjamin Franklin.
Leonardo da Vinci. Thomas Edison. I was Albert Einstein. Nikola Tesla. Alexander Bell Graham. No. It's kind of a tough one.
In school, it was always a male inventor. I just realized.
There's so much. I didn't even know they even know that stuff. You're surprised because they only talk about Einstein and Benjamin, but you never hear a girl in a conversation.
To know that there were women before me,
It gives me like motivation that I can invent something and make maybe like a change in the world, and that would be really cool.
Well, I hope the audio was good enough for you to hearing it. And whenever I hear this and watch this video, it makes me happy at the same time, kind of sad. And I hope there will be a time that women inventors will be as equal of male inventors, and our children, the next generation, will be able to remember women inventors. So by having said that, let's walk into the topic of today, which I'm going to walk you through this Kaggle submission and give you some insight of how question and answering applied in NLP. So an overview of Kaggle competition. Last year, around the same time, by the start of COVID-19 lockdown around the globe, Kaggle Kaggle, which is a world-known machine learning competition in the world, released a format of COVID-19 Open Research Dataset Challenge that is known as CORD-19, and in collaboration with six main partners. And the aim of the competition was to invite NLP expertise and to apply text and data mining tools on the medical community to find the answer that can be important for scientific questions that can help us to fight with this disease. Today, after a year, we are at the stage that we have the vaccine, and some of us even may have our jabs. So, but this has been a long journey, and one of the fundamental challenges at the beginning of COVID, because the disease was very unknown, the scientists needed to understand the literature quite well. That's why this competition was into place. And if you check the website on Kaggle, I highly recommend you to look into it. You will see that how many great inventors and expertise have submitted solutions, and that is showing that how much it was important for the community. Let's look into the data set. The data set at the time of the release of the competition was 167,000 scholarly articles that is incrementally added over time. I believe it is actually much larger now. And then, of course, the topic was the literature on it was all related to COVID-19, the origin of the disease, which is SARS-CoV-2, and all the other related coronaviruses article. So the articles were very, including very kind of contextually, very heavily literature that it was unable for scientists couldn't really go through all the details of it and analyzing it. And then you can find you can find the relevation of the semantic articles. If you go to this, still the articles are there, and you can have a look at it. And also at the same time, I can refer you to COVID-19 search engine that is provided by Azure Cognitive Search people in Corp in Microsoft US, and they have put all this article in a really great presentation, which at the end I can show you the demo of it. So I highly recommend you to check that out. And just to give you an idea of the distributions of the article, and this is just 10,000 thousand of articles that I clean the body of punctuations and all the stopwords and so on. And as you see, the distribution is not even. So we were looking into some of the articles were quite long, over 2,000 or 4,000 words, and some of them could be even much more longer, to 10,000. So you can understand, just get a scale of the complexity of the task. But what are the tasks? What were we asking us the question here? So the question, I am sorry if I can ask my representative, if you close the private chat, I cannot see the screen. That is that possible to close the private chat, RT or Nazia? I don't see the screen myself. If you can, thank you for that.
Lida,
Lida,
you
you
can
can
just
just
click on the
click on
arrow
the
and it
arrow
will
and
go
it will
down.
go down. I couldn't try it. I tried it a few times. I couldn't, but that's okay. I mean, I see my screen as long as the others do not see that. I couldn't.
Everybody can see it.
Okay,
Thank you.
just that's okay. Right. I was talking about the structure of the competition. The competition, at the time of the announce, like March 17 to April 16, the round one conversation was about, they announced 9 tasks that you could submit to any of that. And it was mostly, if you read through the tasks, they are mostly exploratory data. So they wanted to know what are the kind of the risk factors, what do we know about the virus origins and evolution. It's mostly about visualization and data exploring of the information. And in round 2, which was announced of mid-April to June 16, they announced 8 tasks that it was about the summary table, which is known as knowledge extraction. So in this round, they are not asking for what is the kind of the articles involved. It's basically asking for a specific task, that whatever information we can provide, and now knowledge extraction on that. And I have chosen task 4, which is related to diagnostics for COVID-19, and we will read the detail as we go on, just giving you an idea on that. But before we jump into the solution, while I acknowledge the audience may not be all expert on NLP, let's just have a look at what is NLP. Natural processing is a field of artificial intelligence, machine learning, and computational linguistics. So the concept of NLP is how human and computers can understand each other. It's often mistaken that they think that NLP is about text only, but it's also about speech, because speech is a part of human language. So in particular, we want to have a techniques that the machine would understand, analyze, and generate large volume of data of human language. You actually use NLP every day. It's not that something that you wouldn't, you may not even be aware of it. For example, when you search particular keywords, the suggestion on the search engine is an NLP function. Or when you send an email, your email provider does the correction, auto correction, or a spelling. That's an NLP solution. And the most basic one is the classification. When your email provider identify junk and main emails for you, that's a part that that's a text classification. So by having said that, so you see that how applicable NLP is and how every day we work with NLP applications. This is a diagram that I put together, and I have a reason that I put them in different colors. NLP can be simple, NLP techniques can be simple to more complex one. For example, when we're talking about name entity recognition, language detection, sentiment analysis, those are considered quite basic techniques in NLP, although you could have complex scenario to implement them, but those are the challenges that we have overcome. It's not a complex solution for it. It can be easily done. And also we go one level higher, will be a speech to text or text to a speech or language translator, which requires a neural network to understand the target language to compare to kind of the body language, kind of the origin language to target language. That is more complex. And even in a higher level, you will look into the language generation, topic modeling, summarization, word embedding. So those are the things that get more complex in NLP solution, in an NLP application. And there are different approaches to address each of these solutions, but of course we don't have time in this talk. Just giving you an overview of what are the complexity of NLP. Let's start the conversation. Let's now focus on the submitted solution for this Kaggle, and would give you a kind of idea. In Kaggle, this is the particular task that I have chosen. It's related to diagnostics for COVID-19. And as you see, there are a number of keywords in this task. And because I'm a computer scientist, I am not coming from a medical background, so I wouldn't probably understand all these technicality, and I'm not a subject matter on this topic, but what I can understand that there are particular keywords or particular synonyms that it needs to be identified within the text. This is what I can understand as an NLP expert, and that's why kind of I believe every solution that has been submitted, they are not an expert in this subject, but they are expert in data mining, and they kind of identify what needs to be searched, what needs to be found. In Kaggle competition, you will have the if you have tried any Kaggle competition, sometimes you just submit the final result and it will be leaderboard. In this scenario, they wanted you to provide your notebook environment that you work on the solution on, and you have an access to a Jupyter notebook environment with the capacity of 10 CPU and 1 GPU, and a particular memory. So once you want to submit to a competition, to a task, you need to make your private notebook public. And I have done the task on Jupyter Notebook as everybody else. If you go to task 4 on round 2, you probably see my submission. However, the part of this task, because of the complexity of installing Transformers library, I have to use a Linux environment with the structure of NC6 and particular 56 gigabyte RAM. But I share the results at the end with the community. So there's sometimes a complexity. It could be installed there as well. Maybe I probably didn't have enough time, but it's just a little complexity on the implementation that I faced. Looking at the kind of structure of the solution of the Kaggle submission, I'm going to walk you through all these phases, but it's just a very kind of in a way simple representation of what I've done. It's in 3 phases. The phase 1, I look into the Kaggle articles and the diagnostic tasks. That meaning that I try to identify the kind of after all the pre-processing, cleaning the data set and so on, I look into how to find the similar sentences within that long text. that was the main goal of basically phase 1 and phase 2, how we can identify all the similar sentences that have this particular information within each article. So I applied word embedding and applied cousin similarity to identify the top ranked sentences. Don't worry, I'm going to explain all of that details to you today. And after that, the outcome of phase 2 is a good passage of that long article that has the information, but still didn't have the answer of the particular question that they wanted to know. So I apply fine pre-train BERT model to be able to answer specific questions from that model. And again, I will explain what does it mean. But the outcome, the final outcome of phase 3 was the exact answer that we wanted to give to the community. So in data loading, I'm not going to details on that. Basically, you load the data from Kaggle itself, and then as you see on the kind of metadata, how many missing data are available. This is, of course, I would say if you run this comment now, you probably see a lot of increases on the number of articles. This is the result for last year. And then basically the data frame that I was working looks like this. However, after the applying the data pre-processing that most of NLP people expert knows that we often lowercase all the words, remove the punctuation, tokenize all the sentences. In this scenario, it was very important for me to identify sentences, meaning that the sentences that not just a sentence doesn't define in this scenario having a dot, like separate the long sentence, long paragraph by dot. So I apply NLTK tokenizer to identify the sentences because my tokenization is based on the sentences we wanted to extract the top ranked sentences. So it was important to do a proper tokenization on that. And as you can see, that very complex data frame ended up being something like that, that have the sentences and token of the sentences. And of course, there's a paper ID that I would be able to read to join it at the end with the whole kind of data frame, with the original data frame. So after that, we kind of get to the stage now, okay, I have my sentence and my token sentences. Now I want to apply sentence similarity. Sentence similarity is a concept of measuring how similar the two pieces of text are and in what degree you are looking kind of similar sentences. And of course, it cannot be happen in words because how you want to tell the computer, for example, this word is similar of that word. Like it is, I mean, the way they say it is a computational in doing it, not just by showing the synonyms of dictionary. So that's why it's known as word embedding. So you kind of obtain the embedding of the sentences and then you apply the cousin similarity between them. So this is the Google representation of sentence similarity. Feel free to go and check it more. So basically what happened here is in the sentences that you get, for example, how old are you? What is your age? My phone is good. 3 different sentences, which we know already 2 of them are very similar. So you apply the word embedding. Once you apply the word embedding, you will look into kind of it, because after applying the word embedding and the sentence similarity, the cousin similarity, it gives you a measure matrix per each word, and there's a kind of a heat map presentation of it that it shows similar sentences come quite close, whereas not similar sentences like your cell phone looks great doesn't relevant to the old question, how old are you? So that's why it kind of called as it. So this is basically the concept of it. But let's have a look at how we implement that. There's a concept here of word embedding that I keep saying that. So let's just give you an idea what is that. It's a technique that actually map the words and phrases to vectors and real numbers. Remembering the concept of NLP, we want to enable the machine to understand our language. So machine only understand numbers, it doesn't understand words. So we have to convert the words to numbers. That's the main concept of word embedding. So once the words are represented, hello?
Hi. We have you back online.
Sorry.
You can
You can
continue.
continue.
Okay, sorry. I think there was a interruption, but I am back to the call. Thank you. Yes. So in the word embedding, you're looking into. I apologize for the interruption. It's probably the connection problem. In the word embedding, once you have all the words presented in the word embedding, similar words actually appear together. For example, man and woman, queen and king, and also like country and capital, they kind of appear together. And that's a concept that kind of the vector looks quite intense on that. And word embedding, one of the main inventor of word embedding was Google, which come with Word2Vec in 2013. It followed by Glove model from Stanford by 2014, and then Fastest by Facebook. So each of these models apply different ways to word embedding and using different corpus to kind of calculate the embedding, but you can get a different representation of your model by applying each of these techniques. For this solution, I use Word2Vec because it still is the most solid word embedding in general in NLP. In terms of calculating cause and similarity, it's a little mathematical. Again, I don't want to bore you with a lot of kind of technical details here, but there's a concept of term frequency inverse, which is known as TF-IDF, and there's a concept of causing similarity that is kind of measure the similarity, the angle between the two vectors, basically, but the similarity. So the outcome, basically, of applying all this kind of calculation, mathematical calculation to the solution, to the words, we basically, what I ended up having, that I apply cause and similarity on the sentences of each article with the sentences of the task that I have identified, the main key, let's say the phrases that I'm looking for. And at the top of that, you can look into a kind of, you have a top rank sentences that are close to that tasks. And just giving you an idea, this is the outcome of one of the articles of 4,000 words. I ended up having a number of sentences that each of them are having that information about that diagnostic task. So now I kind of scale down the big problem to a more narrower problem, which is rather than an article of, I don't know, 10 pages, I have a few sentences that I need to look into. However, still is not enough. Still, I cannot present this. It's still a lot of text to read and understand. So the next part is kind of applying question and answering, which is the classical NLP task. It is not a new, and there have been a lot of solutions so far, depending on which side of NLP you'll want to look, either by applying transformers or neural network, or even the classical NLP approach. Question and answering has been one of the solid application that always people look answer for it, and it's actually deal with the machine comprehensions in a way that how well a machine can understand the passage, and once you ask a question, it be able to answer that question for you. One of the famous data set is known as SQUAD, which is a stand for question and answering data set. And it is a reading data set. Is a set of Wikipedia articles, and it kind of answer questions, and feel free to have a look at it. They're all open source. And I think I have just a question on can you apply other distance metric? Of course. In cousin similarity, you can have cousin similarity. There are other distance approach that I didn't test on the solution, but of course you can apply. Very good question. I just saw it as I thought it might be answering it. So getting back to question and answering, you could get the kind of the idea. Often this data set is being used as fine tuning, meaning that they use the pre-trained model on this data set to be able to kind of ask a specific question. That is basically happening here for my solution. So the final thing that I want to touch here before we get to kind of the final result and give you some time to ask for a question is BERT. Again, not getting into a very complex solution and technicality on that. BERT is a biodirectional encoder representation from transformers presented by Google in 2019. And it made a big jump in NLP, NLP literature. The reason of that, before BERT, we have the concept of neural network and deep learning was there, and we have the LSTM structure and they which would only look into the neighboring words in the context. For example, if I have a sentence and I would send it to a LSTM architecture, it would look into, for example, a word's before or words after, or maybe you could set it up for 2-3 words around it, but it will never been able to look into the whole context of the model of the text. And what happened, the key technical innovation of BERT, that instead of applying that concept of just layers of neural network, it has a structure of transformer, meaning that it has an encoder and decoder layer with the concept with the attention layer on top of them, meaning that it would understand the contextual relationship between the words and the subwords in a text. It wouldn't be just limited to the neighboring words around the context, around the target. And that's the fundamental change in NLP approaches. And often they say 2019 was a kind of golden year for NLP research. And on top of BERT, on top of transformers now, you get a lot of interesting language model that has been kind of right now within the just 2 years. You see that what a jump NLP has done to this. And again, not getting you to the complex of the architecture of what is encoder, decoder, attention model. It's a very kind of a deep conversation, and I'm happy to have with any of you. If you are interested, please feel free to reach out to me individually. But the concept is, imagine that we have the pre-trained model BERT that has been already can be downloaded. Everybody can download pre-trained language model and use them, right? So this model already has a structure, has architecture that can understand kind of particular has a particular implementation that you don't need to know, but it's a kind of a black box. So when we send the question and the passage that we know that the answer is there, what happened in BERT, because of the concept of encoder and decoder, it kind of find the part that it has the attention model kind of highlighted to the structure. And at the end, after all the layers, and as you see the complexity, it will give you the answer of it. That's basically, it is called fine-tuning model, meaning that you take a pre-trained model, you give the right question and the right passage to it, and it's able to give you the right answer. Basically, that's what happened, the logic of the solution. And it's many solutions actually in question and answering right now, I believe, follow similar logic. Of course, you could try another pre-train, you could try another word embedding, or you could try another distance metric, but the concept, the steps are basically the same. So again, looking at how BERT does that. So this is BERT that in a more detailed view of BERT, it is being pre-trained already on a squad on the data set of question and answering. And when I have a look at my GitHub, I have the link at the end of this slide. You can see that how the BERT is being downloaded or have been implemented. All the code are available. So once you have the question, it kind of identifies the question and the paragraph or the passage by particular keyword. These tokens are important. And it goes through layers by layers. It gives attention. It sometimes skips some of the words. For example, the preposition are skipped, or the particular part of the text that doesn't have those information will be skipped. And at the end, it kind of gives you this very small span that it would be the answer. And what question I send it to this model to fine tune BERT? The questions are all the summary table that have been asked through the community. The type of the study, what we know about the sample, and what measures of the evidence are available. Is it FDA approved, which is important questions for them. And then the paragraph was the top ranked sentences that I have identified from the Kaggle, from the Kaggle competition. And I hope I haven't bored you up to now, because this is the final moment of the truth. So this is a snapshot of the result that I have submitted with the solution. So here we have 20 articles. It's just very simple for the presentation, but you can have a look at the submitted and you see that there are, you could have as many as articles as you want. And here, this is the name of the study link. You could go identifying the journal, and these are the questions being asked through BERT. Of course, not every question has been answered, but the question has been answered are quite accurate. Let's look into the study type. It kind of identified the study type, for example, has been observational or investigation and report, or been nationally, or behavior, and so on. Again, I haven't given any of this information to the model. The model was able to identify it itself because of the capability of BERT, and of course the word embedding that we applied beforehand. And what the method has been detected, like for example PCR, or for example chest X-ray, rapid molecular diagnosis assay. Again, I have no idea about the approach myself, but this is a kind of a right method that been used in this kind of challenges in this disease. And of course, and other methods that has been applied. It's quite interesting about the sample, because the question was what sample is obtained, what is the sample size, and I thought it might mix these two questions, but surprisingly not. It actually answered quite well, because if, for example, the samples obtained is clearly saying is blood, and or for example it's in serum, and in the next one is actually giving the actual sample size, 2 or more weeks. So that is quite impressive, that how can understand this complexity. And or for example, when the kind of a number here, more than 4,000 adults has been as a sample size, that's the model has identified. Measure of evidence, it was able to even capture the function. When I applied the punctuation, I didn't apply the punctuation to remove from the kind of the mathematical formula. That's why, because I thought it's important to the community, to medical community. That's why the punctuation is still there. And then, for example, the speed of assay is something about this solution, the diagnostic, as you see, and is quite an impressive. How can it understand the duration and answer that? And FDA approval, you see that is actually clearly saying the approval, for example, by FDA, or there has been approval, and so on. So I guess the final conclusion here is, imagine of that really long articles that we saw in the beginning and all the complexity. This approach in these 3 phases that I have applied give us this solution, give us this kind of very detailed and specific answer that might be very useful for the medical community. And I highly recommend you to go to, if you find this conversation interesting, please feel free to check up on my GitHub repository. All the codes are available. I also have a blog post that was published on towards data science forum. And if you go to my Medium blog, you can have all the details and explanations on that. And I have one question here. Each row represents the answers from particular link. Is that right? Yes, each row in the result table, each row represents an article. So it's the article name. When it says a study, is the title of the article, and the study link is provided by as a metadata to us. So it's not that I extracted, it was already on the data set. But what I did is at the end, I joined based on paper ID, basically. So that's a study link that means made. The performance measure, how I didn't do the performance measure on this solution at the time that I submitted. It's because I think I need a subject like a SME to understand, somebody who's medical, like kind of medical expert who would kind of tell me that, yes, this article is talking about this. But one of the, I believe if I would have applied a performance measure, I would look into the abstract of the article. Because often in the abstract of articles, they summary all the input on the content. And if you look into the submission solution, a lot of the solution only look into the abstract, which I didn't. I look into the article, to the body of the articles itself. But one way to perform the kind of apply the measure on the performance is just, can we have a look if I kind of get a summary of my abstract and compare it with the findings that I have and see if they are matched. That would be a performance for it. Is that column is made by model? No, the column is just the outcome of the data frame that I joined. If you check my GitHub repository, no, the model didn't generate the model generate answer to the specific question. The final is differing phase 2, phase 3, depending on which phase you are looking. But for easy of the presentation, I put this table together basically. If you check my article, you see that what model outcome is. What is the domain specific BERT models fare better? What does domain specific BERT fare better in this case? I think you could think of any pre-trained model. I use BERT. There are other there's GPT-2, or even if you have access to GPT-3, you could use GPT-3. So I think I choose BERT because BERT is open source and available, and it's a reasonable model to download, and been using in NLP solution for quite a long time. So I use BERT, but you could even in BERT there is a large scale, there is a medium scale. So I guess depending on the BERT model, you may get different result. You may be able to address more question in this link. I'm not saying that it is perfect the answer right now, but of course you change the word embedding, you usually GitHub works better than Word2Vec, so you could change some of the stuff. The next question is it possible that some articles contain the same information? I think that's a very good question. So we do when we apply, like in the pre-processing, we do duplicate, and the duplication apply an abstract. So if the articles have similar, exact abstract, it would probably be deduplicated, right? And however, I think if it has redundant information, let's say when it's sent to the question, to the final question, it probably generates similar question, similar answer. So I wouldn't know, because you're going through a pipeline. I wouldn't look into all the top ranked sentences, but you could apply some of that. Yeah, you could some redundancy you could apply if all the top ranked sentences are similar. You could ignore them because there's a kind of sentence similarity measure, right? The other question that Sandeep has asked, if we were measuring the quality of the model. As I said, I didn't measure the performance on this task. It is basically an exploratory path for me, and I wanted to challenge myself how I can solve such a complex problem. As I said, one measure of, you could change the word embedding, and I would assume GLOV or even fast text might work better on Word2Vec. You could change the pre-trained model, and for measure of performance, it is something that you need to kind of agree. You need a subject matter expert on the solution just to tell you what solution is applied, I think, basically. I have another question. Should perform better, but not sure if there are any healthcare specific models. Very good question, Krishna. I agree with you. I think it is very important on what pre-trained model you fine-tune. I think, of course, if you have a medical fine-tune model, you would apply the better pre-trained model. And you can try it yourself. It's it's still the competition is open. You are referring to BERT. Yes, I agree. I think BERT has different clinical pre-trained model. Summer 2020, I was just like, I had a very limited time. I was doing this next to my work, and everybody was quite sick of lockdown and stuff. So I just tried BERT just to see what the result is. But you're absolutely right. Definitely with healthcare BERT, with the particular model for BERT for healthcare, you will get a much better result. I agree on that. Yes, the abstract itself is a part of the, no, the abstract is a part of the data. So you can have an abstract, the model as a part of the data, but I didn't, as I said, my solution, I didn't use abstract as an input to BERT. What I did, input to BERT was the top ranked sentences from the article. And you could save a lot of time, just send the abstract and ask the question. I agree, but I didn't want to do that because I believed when I look into a lot of submitted solution, I felt that everybody going for abstract, and I wanted to give the community another sense of what would look like if you go for article itself, because a lot of the information are hidden in the article. So that's why I didn't go for abstract. But yes, that's a possibility. I guess I answered all the question here. Once if you are having another question, I want to just highlight again, this is the resources if you like to check out. Thank you for my team in Women in Data Science process. And also I like to, once we are waiting for any question, please feel free to check all the other talks. We have a great group, a series of talks. Please feel free to register and apply, and I hope you find it as useful as this session. Another question, again, Krishna is saying rerun the model with abstract and compare the result. Yes, you can do that. That's what I said. However, I feel, what is my logic of not looking to abstract in computer science article? I would not necessarily put all my important information into abstract of my model. You know, it's just that this is what happened in computer science article. I assume the same logic. So I believe the abstract only contain what is the approach being used and what is the conclusion, but not necessarily having the relevant information that they were looking for. And let's say that not necessarily the article has information for diagnostics, may have it on the abstract. I don't believe that that is the logic here, because it could be the article might be about something else, but it has a particular paragraph about the diagnostic. That's what we wanted to find out. Otherwise, the community would be able to read the abstract themselves. But a lot of competitors, participants, they went to abstract. They only analyzed the abstract, and this solution didn't. That's my message here. I can hand over to the organizer if you want to add more. Yeah.
Hi,
Hi,
Lida. It
Lida.
was
It
indeed
was
a
indeed a
wonderful
wonderful
session.
session.
We see
We
the
see the
learners
learners
asking questions, which feels,
feels,
it's like they have enjoyed the thorough
the thorough
explanation
explanation
from the
from
Kaggle
the Kaggle
task,
task,
your
your
environmental
environmental
explanation,
explanation,
NLP, BERT, the
BERT, the
different
different
methods that
methods
they
that
could
they
use
use
in the
in
problem
the problem
solving.
solving.
And I'm sure
And
with
I'm
the
sure with the
questions being
questions being
answered,
answered,
they
they
have
have
an idea
an
about how
idea
to go about
about
different ways to
different ways
solve
to
the
solve the
problems.
problems.
So,
So,
what you can do,
what you
Lida,
can do,
if
Lida,
you
if
can
you
also
can
share
also
these
share these
links
links
with us,
with us,
we will be
we will be
posting it for
posting
the
it for the
learners to
learners
go
to
through
go
this.
through this. Oh yeah, sure.
And
You mean the resources? Yeah, of course, of course. I'm be happy to. You
sure,
could just
sure.
search my name on GitHub, Lida
Okay,
GH. You see the public and the blog post as well. But sure, I will send you the link to share with your participant. And thank you for the great questions, answering and being very patient on the conversation. I really hope you enjoy this session.
Thank you so much.
Thank you so
And
much.
we also
And we
have
also
Aarti.
have Aarti.
Aarti, thank you
Aarti,
so
thank you
much
so
for
much for
organizing this.
organizing this.
Hello,
Hello,
Aarti, can you
Aarti,
hear me?
can you hear me?
Yeah, I can
Yeah,
hear
I
you.
can hear you.
Okay.
Okay.
All right. So it
All
was a
right. So it was a
wonderful session.
wonderful session.
Thank you,
Thank you,
Aarti,
Aarti,
and
and
thank you, Lida.
thank you, Lida.
And
Oh,
thank you
thank
to
you,
all the
everybody.
learners.
Cheers. Thank you so much, everyone. And feel free to reach out to my Microsoft email or the resources or LinkedIn. And happy to continue the conversation if you're interested in this solution. And enjoy the rest of this series of speech. I highly recommend you to register. Thank you, everybody.
Thank you.
Cheers. Thank you. Bye.
Bye bye.
Bye-bye. Bye. Thank you.